My name is Grace Chen, and this is my honors problem for submission. So first we will insert 20 with coin flips 110. After that, we would like to insert 40 using a random number generator. Oh, so we have 1, 0. So we would put 1, 0 as our coin flips, and we will insert that. After that, we would like to insert 10 and then check our coin flips. 1, 1, 0. So here what we're doing is we're inserting 10 into our skip list. So what it does, it starts from the top row, and then from the top row it checks the next number. If the next number is smaller, then it'll go to that number and then check the number after that. But if it's bigger, it'll go down a row. For 10, it was the case of the ladder, so we went down to the next row and checked the next number again, and because it was still bigger, we went down to the bottom row. At the bottom row, because there's no row we can go to below that, and that bottom row should contain every single element, we inserted 10 between -infinity and 20, and then for the coin flips, because we flipped heads, tails, we inserted it into the next row above and the row above that, but no row beyond that. After this, we would like to insert 20, and then we will check our coin flips. Okay, just as 0. And then after that, we would like to insert 5 and check our generator. It's just 0 again. And then after that, we would like to insert 80. And let's check our coin flips. 1, 1, 0. After that, we would like to delete 20. And then after that, we would like to insert 100. Let's use our random generator. 23, so 0.23, that runs down to 0. And then after that, we would like to insert 20 again, and then use coin flips 1, 0. So what happened here was we started from the top row again to search for where we could insert 20. So when we checked the next number, we were at 10. So because 10 is smaller than 20, we were able to check the next number. However, because 80 is bigger than 20, instead of going to 80, we went down to the next row, and then we checked the next number there. Because 40 was bigger than 20 as well, we went down to the last row. And because there's no row we can go below after the bottom row, we inserted 20 between 10 and 40. And then because our coin flips were heads and then tails, we inserted 20 at the row above, but not any row after that. Now we would like to insert 30, and to check our coin flips, we'll have 0. And then after we insert 30, we would like to delete 5. Now what happens when we were deleting 5 was we started from the top row again, and then we checked the number after that. Because 10 is bigger than 5, we went into the next row, and then as the same thing happened there, we went down to the bottom row. At the bottom row, because every element has to be present there, we were able to find the 5, and then it was removed from our list. Because um, the bottom row should have every single element. Once that was removed, if there were any subsequent 5s in higher rows, those would have been removed as well. However, because those were not there, that was not shown. Now we would like to insert 50, and then let's check our coin flips using our number generator. All right, so that rounds down to 0. And then after we inserted 50, we would like to look up 80. All right, so what happened there was we started from our top row, and then we checked if our next number from negative infinity to 10, if 10 is smaller, since 10 was smaller, we went down to the next number, which was 80. And then because at 80, the next number is bigger than what we were looking for, so we went down instead. So then we checked 80, and then because the number after that was still bigger, we went down to the bottom row. And then when from there, we checked if we had found 80, and then we did. Now using the steps for that last operation, the reason why skip lists are efficient and why they're better than a simple linked list is because in a skip list, we have multiple rows, and then each one higher than the last one has less elements, which means that when we're searching through a skip list, we don't have to search through every single element. As you can see here, when we were searching through 80, we had to go negative infinity, 10, and then 80, and then we found it. However, in a simple linked list, all of our elements are all at the bottom, and we have to search through every single one. So to get to 80, we would have gone negative infinity, 10, 20, 30, 40, 50 to find 80. Because of this, a simple linked list search would actually run on n time because you have to search through however many elements there are in the list. However, in a skip list, because each higher list has less elements than before, and you're just checking to see if the element on the right is larger or not, we don't have to go through, there is the possibility of like going through less elements because there's just less numbers to go through, and we're able to skip through assuming that the number to the right is like smaller than the number that we're looking for or trying to insert. So because of that, um, a skip list is more efficient and actually will run on log and time.